Java Jangwali Java Gnartha. Welcome to the winding chemistry of ffcbmd, fashionable film city, Bollywood movie developer. Now today we will learn about Hund's rule of maximum multiplicity. So it states that electrons in any subcell like S, P, D or F occupied orbitals singly with parallel spins before pairing in any orbital commences. In other words, the pairing must begin with the entry of second electrons in the s orbital, the fourth electron in the p orbital, the sixth electron in the d orbital, and eighth electron in the f orbital. The arrangement of electrons in first 6 elements under Hund's rule of maximum multiplicity can be explained as follows. Element hydrogen, symbol H, atomic number 1, its electronic configuration 1s sup 1, and its electronic distribution in orbital up arrow in a square block. Element He, helium, atomic number 2, its electronic configuration 1s sup 2, and electronic distribution in orbital up arrow and down arrow in a square block. Lithium, Li, atomic number 3, electronic configuration 1s sup 2, 2s sup 1, and orbital configuration up and down arrow in a first square block and up arrow in second square block. Next, beryllium, symbol Be, atomic number 4, electronic configuration 1s sup 2, 2s sup 2, orbital configuration up and down arrow in first square block, up and down arrow in second square block. Next, B, atomic number 5, electronic configuration 1s sup 2, 2s sup 2, 2p sub x sup 1, 2p sub y sup 0, 2p sub z sup 0. Orbital configuration up and down arrow in first square block, up and down arrow in second square block, and up arrow in first square block. Next is C, carbon, atomic number 6, electronic configuration 1s sup 2, 2s sup a sup 2, 2p sub x sup 1, 2p sub y sup 1, 2p sub z sup 0, and its orbital configuration up and down arrow first square block, up and down arrow second square block, up arrow in third square block, up arrow in fourth, third second square block. Thus, if there are 3 electrons in p orbital in atom, then each orbital will be singly occupied, and the arrangement in ground state will be like p sub x1, p sub y, p sub x sup 1, p sub y sup 1, p sub z sup 1. So all p square block will be filled with up arrow. not like this. P P sub x sub 2, P sub y sub 1 and P sub z sub 0. That is first a square block filled with up and down arrow and second a square block with up arrow. This is wrong configuration, but first one is right configuration. If there are 7 electrons in 4f orbitals, the arrangement in the ground state will be like all the 7 square blocks of 4f orbitals will be filled with up arrow, and any another configuration will be wrong. Like for example, 7 square 4f for a square block of 4f orbitals, that is first block is filled with up and down arrow and another is filled with up arrow, then it is wrong. Similarly, first is filled with up and down, second is filled with up and down, third is filled with up, fourth is filled with up, and fifth is filled with up, and other two blocks are vacant. It is also wrong. And next, first is filled with up and down, second is filled with up and down, third is filled with up and down, fourth is filled with up, and other three block is vacant. It is also wrong. But first is filled with up, second is filled with up, third is filled with up, fourth is filled with up, fifth is filled with up, sixth is filled with up, and fifth is filled with sixth is filled with up, and seventh is filled with up, then it is right. That is 7 electrons in 4f orbital will be filled like as told earlier. This rule is found to be quite helpful in describing the position of an electron. Electrons tend to avoid being in the same orbital as far as possible, and electrons tend to have the same spin if they are the equivalent orbitals. Like suborbitals, example as P sub x, P sub y, and P sub z dash tend to become completely filled or half filled, since such orbitals are more stable than any other orbitals. Now let's see some anomalous configurations. A study of the table shows that experimental configuration of some transition elements, that is D block elements, are different from their expected configuration. Let's discuss it. Let's consider D series. Element with atomic number 24, that is chromium, Cr sub 24. Expected valence shell configuration is 3d sub 4 4s sub 2, but its actual valence shell configuration is 3d sub 5 4s sub 1. Similarly, for D3D series element Cu sub 29, its expected valence shell configuration is 3d sub 9 4s sub 2, but its actual valence shell configuration is 3d sub 10 4s sub 1. Similarly, for ND series, we see it one by one. That is NB sub 41. Expected valence shell configuration 4d sub 3 5s sub 2. Actual valence shell configuration 4d sub 4 5s sub 1. MO 42, that is MO sub 42. Expected configuration 4d sub 4 5s sub 2, but actual is 4d sub 5 5s sub 1. Next, RU sub 44. Expected configuration is 4D sup 6 5S sup 2. Actual is 4D sup 7 5S sup 1. Next is RH sub 45. Expected is 4D sup 7 5S sup 2. Actual is 4D sup 8 5S sup 1. Next is PD 46. Expected is 4D sup 8 5S sup 2. Actual is 4D sup 10 5S sup 0. And next is AG 47. Actual is expected is 4D sup 9 5S sup 2, and actual configuration is 4D sup 10 5S sup 1. Similarly, for 5D series, it has two elements. PT 78, it is expected configuration is 4F sup 14 5D sup 8 6S sup 2, but its actual configuration is 4F sup 14 5D sup 9 5S sup 1. Similarly, for AU 79, expected configuration is 4F